You hear the term big data all the time, right? But it's so much more than just a buzzword. It's really about a fundamental shift in how organizations can find new value. We're talking about tapping into what is probably the most valuable asset any company has, its information. Okay, let's really dive into this. And this, right here, is the question at the heart of it all. I mean, we are drowning in data. It's coming from everywhere, all the time. But how do you turn all that noise, all that raw information, into a real, actual competitive edge? Well, that's where Big Data Analytics, or BDA, comes into play. It's the toolkit for finding that all-important signal in the noise. And the promise here is, it's incredibly real. For businesses, this means things like running a much tighter ship, driving efficiency, creating products that feel like they were made just for you, and that, of course, boosts customer satisfaction. For science, wow, it opens up completely new avenues of research, giving us insights that were literally impossible to get before. So to really get a handle on BDA, we first need to understand that analytics isn't just one single thing. It's more like a journey, an evolution in how sophisticated our questions have become over time. I love this analogy. Think of it like driving a car. At first, you're just looking in the rearview mirror, seeing what's already happened behind you. But as you get more advanced, you start looking through the windshield to see what's coming up ahead. And eventually, you're not just looking, you're actually taking the wheel and steering toward exactly where you want to go. So stage one is descriptive analytics. This is the foundation, right? It's all about looking in that rear view mirror. Think about your standard business reports, your dashboards that showed last quarter's sales figures. It answers that one simple but absolutely vital question: what happened? Next up, we get a little more curious with diagnostic analytics. It's not enough to just know that sales went down. Now we want to know why they went down. This is where we start digging into the data, looking for the root causes and the hidden relationships between things. Okay, now we're looking through the windshield. This is where things get really, really powerful. Predictive analytics takes all that historical data and uses it to build models that can forecast what's likely to happen next. We're shifting from just reacting to the past to actually preparing for the future. And this brings us to the absolute pinnacle: prescriptive analytics. This is where we grab the steering wheel. It answers the ultimate question: how can we make our desired outcome happen? It doesn't just predict what's coming, it actually recommends specific actions to take. This is the point where data isn't just informing decisions, it's actively driving them. So, you might be wondering, how did we get to a place where we can do all this advanced stuff? Well, it took a pretty fundamental shift, mainly because the data itself changed. The old ways of doing things, the old models, they just broke under the sheer volume, speed, and variety of all this new information. This chart really gets to the heart of it. The old way, traditional business intelligence, was built for a world where all your data was neat and tidy, structured in rows and columns on one big central server. Big data completely flips that script. The data is spread out everywhere on tons of machines. It can handle any kind of data: spreadsheets, photos, videos, you name it. And it introduces this really cool, kind of backward idea. You move the code to the data, not the other way around. And this quote just brilliantly explains why that makes so much sense. Think about it. When you're dealing with terabytes or even petabytes of data, it's just way, way more efficient to send your tiny little analysis program over to where the data lives, instead of trying to drag all of that massive data across a network to your program. It's simple physics, really. Now, this whole new way of thinking demanded a whole new kind of technology to power it. And that technology is NoSQL, the database engine that was basically purpose-built for the crazy scale and variety of big data. First things first, what does NoSQL even stand for? A lot of people think it means no to SQL, like it's anti-SQL, but it actually means not only SQL, and that name perfectly captures the whole philosophy. It's about a world of databases that aren't stuck with the rigid, table-based structure of those traditional SQL systems. And these are the core features that make it so perfect for today's world. They're designed from the ground up to be distributed across tons of cheaper machines. They have what's called schemaless flexibility, which just means you don't have to define your data structure perfectly ahead of time. And a lot of them were literally invented because giant web companies needed to solve massive scaling problems that old databases just couldn't handle. See, NoSQL isn't just one thing. It's a whole category with 4 main flavors, and each one is optimized for a different kind of job. You've got key value stores, great for things like managing a shopping cart, Column-oriented databases, perfect for analyzing huge social media feeds, document stores for real-time analytics, and graph databases, which are the secret sauce behind a lot of recommendation engines. And here are just some of the big names you'll see out there in the wild. For each of those types, there's this whole ecosystem of popular, often open-source databases. You've probably heard of some of them, like Cassandra, MongoDB, or Neo4j. Each one has a massive, thriving community behind it. But like with any big technological leap, NoSQL isn't a magic bullet. It comes with its own set of trade-offs, and its rise to fame certainly doesn't mean the story of data management is over, not by a long shot. So what's the catch? What do you give up? Well, to get that incredible scale and flexibility, NoSQL databases often relax some of the super strict guarantees that traditional databases have. These are known as ACID properties. Basically, they would ensure every transaction is 100% reliable and the data stays perfectly consistent. Think of a bank transfer. It has to be perfect. By relaxing those rules, you gain massive performance and availability, but you might lose some of that perfect consistency. And that very trade-off has led to the next step in the evolution, something called NewSQL. This is a newer class of databases that's really trying to give us the best of both worlds. The goal here is to get that massive, add more machines scalability of NoSQL while still holding on to those rock-solid ACID guarantees of a traditional database. Which kind of leaves us with one final big thought. We've seen this incredible journey, from just asking what happened to actively prescribing how we can make something happen. But our ability to collect data is just continuing to grow exponentially. So the race is really on. Will our technologies for finding answers always be able to keep up with the new, more complex questions we keep thinking of?